All right, so we are back with more Let's Translate Physics. We're going to stick with the topic of E&M and move into Griffiths Introduction to Electrodynamics, 4th edition. I have always admired Griffiths in his savviness when writing this book, because he's got sections where he literally copy, pasted, and modified. So like physical interpretation of bound charges, flip over 100 pages to the right, physical interpretation of bound currents. First sentence, in the last section we found that the field of a magnetized object is identical to the field that would be produced by a certain distribution of bound currents. And then back here he said, in the last section we found that the field of a polarized object is identical to the field that would be produced by a certain distribution of bound charges. And so he's literally using the same wording, he's just subbing out electric charges for magnetic currents. And it's actually a brilliant move because it helps emphasize the kind of parallel nature of electric fields and magnetic fields. I just wish they weren't separated by 100 pages. So I've actually taught this class in the past where we went straight from the section on electric fields to the section on magnetic fields, and then we did electric polarization and then magnetic polarization, or magnetization, excuse me. So what I'd like to do is take these two paragraphs where he introduces these bound charges and bound currents and see how Google Translate treats them. I'll start by putting those two sentences side by side. In the last section, we found that the field of a polarized, I need to do some spell checking here, that the field of a polarized object is identical, yep, to the field that would be produced by a certain distribution of, and I'm going to include the quotation marks, bound charges. Now I'm not going to try to include the sigma b and rho b because that would just be ridiculous b. Let's go over to the other page in the last section. Ooh, he put a comma on this one. So interesting, there's a comma in section 6.2.2, but not in section 4.2.2. Interesting. In the last section, we found that the field of a magnetized object is identical to the field that would be produced by a certain distribution of quote-unquote bound currents. Was bound... Oh, another interesting difference. Bound charges is all in quotes in section 4.2.2, and then, but just bound is in quotes in section 6.2.2. So maybe he wasn't copying and pasting this. Maybe he just surreptitiously wrote them the same way. Now, what I'm really interested to see is how these translations differ by the time we go through about 5 different languages and get back to English. I'm really curious to see what happens with these two, because you've got basically the same sentence, except polarized is replaced by magnetized, and bound charges is replaced by bound currents. Right? So I'm really interested to see how it treats those two sentences. Like does the difference in between currents and charges affect the translation of the word bound, or affect some other translation somewhere? So we'll go to, let's go to Yoruba first. So that's fine. I already see that there's a difference in the beginning because it's translating in the last section. We found that it's giving me a different thing because it's giving me a comma here and not a comma here. So the comma is actually making a difference in the initial language. I said copy here. I think I just have to swap languages. Is that right? Yeah. Okay, yeah, so there's already a difference when I go back to English. In the last section, we see that the space of an authorized object is marked to the point that it will be populated by a distribution of charge points. Whereas the magnetization one comes out in the last section, comma, it is found, so we go from the active voice to the passive voice just because of the comma. Wow, that's amazing. That's really amazing. It is found that the magnetic field is identical to the point that will be generated by a distribution of bound currents. Okay, so I kept that part pretty good. The charge points is interesting. All right, let's keep this thing going forward then. Let's go with, we got to throw in Russian at some point. All right, so there's our translation to Russian. I'm going to always copy these just to be safe, but I think all I have to do is swap languages and then move this one forward. All right, so we're on language 2 by now, or we just got done with language 2. Let's go with Greek next. Okay, so that's now swap number 3. Copy it for security's sake. Swap these. Let's see, this is going to be swap number 4. So this will be our last stop before we get to English again. Let's go with, let's go Chinese. Let's go Chinese traditional. Go. All right, we'll copy, swap, and now let's get back to English and see what happens. All right, in the last section, we finally got a comma up here. So somewhere along the way there, we ended up with a comma up here. That's great. In the last section, we see that the space of the authorized object has been marked to such an extent that it is filled with the distribution of charging points. Okay, so that actually didn't change too much as we went around and around. That's pretty cool. In the last section, it was found that the magnetic field was the same as the point produced by the distribution of the coupled current. So it's no longer a bound current. Or excuse me, it's no longer a... What was it originally? It was originally bound currents. Now it's coupled current. That's actually interesting that it translates that as a coupled current, because it's talking about 2 bound currents, one on the surface and one in the bulk of the material. So that's actually kind of interesting that it translated that a coupled, because it is a coupled current, one on the surface and one on the interior. That's interesting. Okay, let's do one of these paragraphs. Ooh, I want to do one from 4.2.2. So we'll say, in the last section, no comma, we found that the field of a polarized object is identical to the field that would be produced by a certain distribution of quote-unquote bound charges. But this conclusion emerged, this is going to be great, in the course of abstract manipulations, but this conclusion emerged in the course of abstract manipulations on the integral in equation 4.9, that will always be interesting to do, comma, and left us with no clue as to the physical meaning of these bound charges, period. Indeed, comma. Some authors, he's not dropping any names here, he's just saying some authors, give you the impression, why would you read a book other than Griffiths, my goodness, that bound charges are in some sense fictitious. There's a dash there. I guess I'll put it 2 dashes there. I don't know. This one will be fun. Bookkeeping. It's 1P. Got carried away with the double letters. Bookkeeping devices used to facilitate the calculation of fields. Nothing could be further from the truth. The bound charges. He actually says rho B and sigma B. I'm just going to place them with the bound charges, which is what he called them earlier. Represent perfectly genuine accumulations of charge. This is going to be great. In this section, I'll explain how polarization leads to these charge distributions. And just a little note for you, Griffiths, you said in this section, you're really in a subsection at that point. So actually, let me make a little editorial change there. In this subsection, I'll explain how polarization leads to these charge distributions. All right, that was a lot of typing. So just in case I lose this, I'm going to paste this into Notepad here. So this is going to be Griffiths 4.2.2, just to keep it handy. Pause for edit. All right, here we go. Let's go Chinese first. Copy, swap. Let's see. In the previous section, we found that the field of a polarized object is the same as that produced by a certain distribution of bound charges. But this conclusion appeared in the process of abstracting. Ooh, abstracting? What was it originally? Oh, of abstract manipulation. The integrals in equation 4.9 and did not make us know anything about the physical meaning of these bound charges. Did not make us know. Did not make us know. It was originally left us with no clue. So instead of left us with no clue, it's did not make us know. Indeed, some authors give you the impression that bound charges are fictional in a sense, just bookkeeping devices used to facilitate field calculations. The truth is incomparable. The bound charge fully represents the true accumulation of charge. In this section, I'll explain how polarization causes these charge distributions. Okay, let's go around the circle here. Let's go Persian. Let's pick some different languages this time. Let's go Persian. Copy. Flip that around. And we'll pick, let's go Irish. Yes. All right, copy just in case. Let's see, we got Chinese, Persian, Irish. I need one more. Let's go Slovenian. Go, copy this. Permute it back, and now let's arrive back at English. In the previous section, we find that the polarization field is the same as that obtained by a given finite load distribution. Finite? Where did finite come from? Oh, did finite come from bound? Bound meaning the opposite of unbounded, and unbounded meaning infinite? Oh, that's interesting. That's really interesting. Finite load. I don't know where load came from. Oh, it's charge, like the thing you are charged to do, and that's the load you have to carry? Oh, that's interesting. But this conclusion appeared in the process of abstraction of integrals. Abstraction of integrals, as opposed to abstract manipulations on the integrals. Abstraction of integrals in equation 4.9. It did not give us the physical meaning of these finite loads. So finite load got translated consistently. In fact, some authors give the impression, impressions stuck through. That's interesting. Some authors give the impression that the limited cost, okay, so bound charge has been turned into finite load and limited cost. Oh my gosh, then of course it's the accounting tool. So now we're in an accounting textbook because we've got a limited cost accounting tool. Oh my gosh, we just jumped from electromagnetism to accounting, used to facilitate field-based computing. The truth is incomparable. A limited load fully represents the actual accumulation of burden. In this section, I will explain how polarization distributes these loads. Wow, now we're into accounting and workers' rights and equal load and all this stuff. Oh man, this is great. This is wonderful.